another weird thing about schedulers. So let me change the scheduler. So recall when we last looked at the iosched directory, we had the front merges, read expire, write expire. And now we don't have those things anymore because you changed the queue to be fair queuing, or I changed the scheduler to be fair queuing, and fair queuing has its own tunables for how the fair queuing works. Right. And if I switch back to the default for this machine, which was none, there's no iosched directory because if you're not doing any scheduling, there's no tunables for scheduling. Exactly, because there's none. So depending on your scheduler, you'll see different things in that iosched tunables directory because there's different tunables to be had. In the show notes or the episode description, there is a great kernel document that documents like all the different schedulers and their tunables and what their tunables do. And so we'll make sure that that's there. I think it may already be there in the show notes, Nate, because it was in the episode.
I will get it added. I did not copy that far down. I see it now at the bottom of the links. I'll make sure to get that added.
Fair enough. We can just copy and paste it and throw it into the chat.
Yes, exactly what I'm doing.
Cool. So that's kind of how IO scheduling works and symbols. Let me switch back to MQ deadline. You'll remember when we were last running MQ deadline, I changed the write expire and I set it to 50,000, but now it's reverted back because I switched to another scheduler and then I came back and it just got all the defaults. So the next thing is like, how do we keep these things that we're changing from not being the defaults when they get changed again? And so there's not a great answer to this, but here's what I found. What we can do is go back into our tuned profile, and tuned has the ability to execute scripts when a tuned profile is put into place. So I can go into my Etsy tuned virtual guest mine, and I can create a script. And I'm just going to call my script disk tuning sh. And I'll make it a bash script. And this was write expire. All right, and I'll make it executable. And then I'm going to go into the tuned profile that goes along with this disk tuning I want to do. And I'm going to add another stanza into my file called script. And I'm going to say that the script I want to run when this profile is set is the name of my script. And so now when I do my tuned profiling, all right, so I'll switch to another profile so I get some parameters. Then I'm going to go back to mine. So now it should set the scheduler to deadline, and it should have changed my write expire, right? So it's like, these are the parameters I want to set and the values I want to set to them.
There you go.
So you tuned profile, you reference your shell script you want. In the shell script, you actually like send all the data into the individual files in memory that you want to change. And then whenever you select that profile, those are the things that get set automatically.
So I know you suggested that this feels like an odd way to set these. Like, why aren't they just variables that you can set? But now that I've seen you do it, and the conversation we had earlier about workloads that have different physical disks for different purposes, right? It makes a lot more sense that there's a script in play, because I could say something like, this disk where my high performance database lives needs these tunes, and this other disk where my operating system lives or my log files live or whatever does not. So you can be a little more specific with a script than you could with just tunable like variable names and whatnot. So it actually makes more sense, I think, when you think about it that way.
Well, it's more granular, right? We can like pick the individual parameters we want to change. There's a couple other things like, oops. Right starve here. So this is one where like the number means different things. This is a value of milliseconds. And it says, this is how long I will allow the system to not do writes that may be scheduled. So I can starve the writes for this amount of time. So we could like tweak that if we wanted, because we really didn't care that we're not doing disk writes, in addition to things like expire time. Just because there's like too much read coming in and jumping the queue in front of the writes. There's in the queue directory, not in iosched, there's low latency, I think. Oh, I'm not seeing it. I had found it earlier. Maybe that's in a different scheduler. But there's things like it'd help if I look at the right. Looking at the right thing.
Can we make it add random data to every write? That would be fun.
Yeah, let's take it. So in our request, this is the queue size for this disk, right? In just a number. We could make this larger, but if we make this larger, we'll have to do more memory. And that might be okay. Maybe you have like a busy disk IO subsystem and having that you need this to be larger so that you're not refusing requests or using other memory to store stuff. But it's something that's not included in the tuned profile disk subsystem by default. And so this is something you could throw into your script to tweak for the specific disk. The reason that read ahead is in the disk profile for tuned is because that's a pretty common to tweak one based off of the disk file size that you're working with. These others are a lot more exotic.
And is that maybe included in all of the different queuing strategies except for none? That it could be a generic value like that included at the top level, whereas these other things could change based on what queue you set or what profile you set.
So anything that is elevator or disk scheduler specific, we should see under iosched. Right. These top level ones stay pretty much the same.
Okay.
Right. So like here's my number of requests, and there's the read ahead KB somewhere in here, right there. Right. So these are like regardless of scheduler. The scheduler ones are where like now that I've picked the disk IO type that I want, these are the additional tunables that I can tweak for it. Cool. So yeah, let's kind of deep dive in the weirdness of schedulers and how you make them persistent on the machine.
So now go schedule all of your disk IO and learn all the pitfalls and then regret your choices and revert back.
Well, I mean, we're talking about all the things that you could do, right? But realize that we also talked about like, well, I have to know what kind of storage I'm using on the back. I need to know that if I'm queuing more things, I need more memory, right? So you can actually put more memory utilization on the system because you've changed your disk IO settings. I need to know whether my IO is write heavy or read heavy. And do I want to bias my IO towards one or the other? So like for whatever reason, if you like really wanted to save files, you could use deadline, but flip-flop like which is preferred by making the writes expire really small and the read expire really big. I wouldn't recommend it. That would like kill your system performance, but you could do it, right? And this is where like knowing what you need to shape and how to shape it and how the consequences of shaping it look can be really
right.
But yeah, so none, MQ deadline. Those are the big ones. Those are the choices that you should make. And if you're a laptop or you want a balanced mix between reads and writes, you can use BFQ.
Awesome. So a whole bunch of information that I hope folks have pulled some valuable gems of information out of here.
Nate, did you pull any valuable
Yeah, I
gems
mean, there's a
out?
lot to parse there. I'll say that. I do have a better understanding, I think, of how this is meant to work and why you would change these things now, which is good. Which is good. I have had some exposure to these now that I've seen some of the terminology. I've never gone to the kernel level to change them, but I remember when we were like researching storage arrays and whatnot, I had to do a whole bunch of learning about, how this array writes data and how you can change the scheduling at that level and all that. But I've never done it at the Linux level.
Yeah, and disk arrays are another great example of like why you might set a scheduler per device to something
Right.
different. So, when you send data to your disk array, it's going to do its own thing for ordering reads and write requests and stuff too.
Right.
So depending on how it interacts there, you might choose none,
And
or you might go always send the reads first because I want those back.
a lot of those nowadays get super complicated because they're trying to do all kinds of tricky things with storage to try to make it, more efficient or deduplicated or more resilient or faster or whatever, right? Based on your needs.
Yeah, there's stuff like the multi-tiered storage where it's like there's a whole bunch of RAM essentially that stores a bunch of things.
And then there's SSD, then there's spinning disk.
Yep. So yeah, like we can control the Linux things. We can't control the like everything that happens after the Linux things.
Right.